before starting the next tutorial, that is how to make Koha enable uh, to handle different kind of Indian regional languages for indexing and retrieving, we need to know a little bit about text encoding schemes. So in this particular tutorial, we are going to learn different text encoding schemes, including ASCII, American Standard Code for Information Interchange, and ISCI, Indian Standard Code for Information Interchange, which is actually nothing but extended ASCII. And then we will be learning what is Unicode through a presentation. Okay. But before proceeding further, there is a misconception what I found um, in LI students that computer understands 1 and 0 only. In fact, in this particular tutorial, we are going to tell you that computer even do not understand what is 1, what is 0. And then why we always talk about 1 and 0, the binary representation of numbers or characters in computer? Because of this simple reason. Computer inside the system understands only presence of signal. Presence of signal is represented by plus 5 volt, and minus of minus this minus 5 volt represent absence of signal. So computer at the core of the core only understands the presence of signal plus 5 volt and absence of signal minus 5 volt. But for a human mind, it is very difficult to process that kind of signal pattern. That different kind of combination of presence of signal and absence of signal. So for the sake of easy understanding on our part, we actually represent presence of signal as 1 and absence of signal as 0. And there lies the misconception that computer understands 1 and 0. If it can understand 1 and 0, it can understand everything, because the concept of 0 is a very difficult one for a human mind. Even till date we do not understand properly the concept of 0. On the right hand side there are infinite number of positive integer, on the left hand side there are infinite number of negative integers. So it's a very complex conception to perceive, and computer simply do not understand it. So that is the logic why we use 1 and 0. We use 1 for present to represent presence of signal, and 0 for absence of signal, and 1 and 0 is called bit. And as you all know that 8 bits, the chunk of 8 bits, either 1 or 0 or combination of 1 or 0 represents a byte. Okay. So with this brief introduction, let us see that how computer understand character, and what is the limitation of ASCII and ISCII, and why people have moved towards Unicode, and how that Unicode based text retrieval engine can be implemented in different library uh, library software system. Mainly text retrieval engines are responsible for managing different kind of indexing, and in Koha that is Zebra. In case of DSpace it is either Lucene or Apache Solar. In case of Viewfind it is Apache Solar. On the other hand, Greenstone uses actually Greenstone offers three different options for text retrieval. One is MGPP, managing gigabyte plus plus. One is this one Lucene, and the latest version of Greenstone 3.10 also offers Apache Solar as a text retrieval engine. Similarly, Koha also offers two different text retrieval engine. One is the default one, that is the Zebra, which is very good to handle structured data like mark records, like record based on common communication format or Unimark. And on the other hand, Koha presently offers another options for text retrieval, that is called Elasticsearch. Elasticsearch is good in handling both structured data like mark records, as well as unstructured data like full text document attached with a record, or like a book, the whole book, ebook, or that kind of thing. So anyway, before proceeding to the next tutorial, we need to know a few things. Then the computer, we understand now that it represents only presence and absence of signal, and combination of presence and absence of signal actually creates different kind of data or information. And computer stores data and information including image, character, numbers, everything available in your keyboard is basically represented through a set of standard codes which is normally available in every personal computer or laptop or desktop. That is called ASCII, American Standard Code for Information Interchange. Okay, so if this is the preliminary knowledge we are having, then let me show you that how a decimal number can be transformed into its binary equivalent. So let us suppose take 65 as a decimal number. So 6510. So what will be the binary equivalent of this 65 decimal? People normally follow a different kind of technique by dividing 65 consecutively with 2 and storing the remainder. That's a very complex process, and if the ordinal value of the number increases, it takes much time and there is often a chance of mistake. So I recommend my students to follow a scale like this. Say for example, this scale, what we have displayed here, that is a binary scale, because you can see that every digit or character in computer is represented through presence and absence of signal, which is represented by 1 and 0. So base is 2. That's why it is called a binary numbering system. So in that binary numbers in numbering system, just like your decimal number is built in that way. For example, let us take a decimal number to understand this particular fact. Say 456. How this number is built actually? So now this number is basically 4 into 10 square, then plus 5 into 10 to the power 1, plus 6 into 10 to the power 0. So every decimal number we are handling is actually we built in this way. Okay, and if you add this up, it will become say 400 plus 50 plus 6. So altogether it is 456. Here you see that every digit is contributing according to their position. So 6 is unit place. So 6 into 10 to the power 0. Anything to the power 0 is equal to 1. The mathematical formula is a to the power 0 is equal to 1. So 6 into 1. Then this 5 is actually the decimal place number. So 5 into 10 to the power 1, and 4 is basically the 100 place number. So 4 into 10 square. So every decimal number actually based on this significance of the digit in a position. That's why this is called positional numbering system. In compare with the Roman script like 1 2 3 4, what we use normally, that is basically non-positional numbering system. For example, in Roman script, the rule is that you can write 1, 2, 3. So I'm skipping 4 and 5. So 4 is what? 5 minus 1. Because the rule of this non-positional numbering system in Roman is basically, that you cannot write 4 consecutive similar digit. So 1 2 3 maximum you can write 3. So if you want to if you want to write 4, then it will be not 1 2 3 4. It will be 5 minus 1. So in this way, this Roman number is basically having this kind of thing: 1 5 10, and you see here it represents our finger actually. One is one finger. Then if you are creating a kind of all five fingers of a hand, it becomes a symbol of V. So V represent 5. Then double V, which is basically X, that is represent 10. Then there is L for 50, C for 100, D for 500, M for 1000, and so on. So in this way, these are the base of Roman script, and you see no digit is actually, or no symbol is actually representing any kind of positional value. For example, if you want to write 1564 in Roman numerals, which is the birth year of Shakespeare, William Shakespeare. So we have to write M for 1000, D for 500, then L for 50, and then remaining is 40. So X 40. So in this way, we can represent a number in Roman, which is a non-positional numbering system. And this the contribution of this positional numbering system. The concept of zero came from India, and spreaded all over the world through Arabian businessmen. So that's why it is called Indo-Arabic numeral. And this is the biggest contribution of India in science, because you imagine a world with this kind of MD, LX, IV kind of number, and the science presently we are having, could not be possible. As you are, taking part in this virtual certificate course, that will maybe another thousands year after that may happen with this kind of numbering system. So it's a great contribution to the science and technology by Indian mathematician, by perceiving the concept of zero, and distributed the concept throughout the world, which is the default numbering system, the default positional numbering system in the world. So let us now move towards how it is represented in computer. Say for example, I want to convert this 65 decimal, which is actually built by using different kind of unit place, 6 into 10 plus 5 into 10 to the power 0, so 65. Now 65 includes 64, 1. 65, let me make this as this particular table. Let me make this center position. Okay. So then 64 we have already taken. So another 1 remains. So 1 signal will be there. In the rest of the position, signal will be 0. So easily we can represent 65 is the binary equivalent is 1, 1, 2, 3, 4, 5, 0, 1. And in computer, this 65 represent as a discrete digital signal, presence of the voltage or presence of the signals and absence of the signal. So in this way, you can take any number, and you can convert any decimal number you can take, and you can convert into their binary equivalent. If you this particular number you can see 1 0 0 0 0 1, it's a 1 2 3 4 5 6, a 7-bit number. So if we represent it's a 8-bit number, we can easily represent as in this fashion. So this is the 7-bit, and I can represent that as say for example 0 0, then 1 1 2 3 4 5 1. So you can always add 0 in the left hand side to convert a 7-bit ASCII code into an 8-bit ASCII code. So this is binary. This is also a binary number, and this is basically 7-bit. This one is a 7-bit. You can write it's a 7-bit because 7 bits are there, and the moment we add a prefix 0, it becomes a 8-bit ASCII. So that's simple. So any number can be represented as a 7-bit one or 8-bit one. Now let us take the case of 255 decimal. So 255 decimal, 256 is not there, so 0. I'm just preparing an 8-bit ASCII. Now 128 is present, 64 is present, 32 is present, 16 is present, 8 is present, and so on. Because why I am saying these are present, because let us you just add it up. Say 128 plus 64 is equal to say 188 plus 4 192 plus 32, it becomes 4, then 2 2 224. Then we have 16 plus 16 plus 8 plus 4 plus 2 plus 1. So 224 plus 60 becomes 30, 240, 248, 252, 254, 255. So in every position there is a a presence of signal. So we are representing 1, 1, 1, 1, and this will also be 1. So we can easily represent that 25510 is as 8-bit ASCII 0, 1, 2, 3, 4, 5, 6, 7, 8. It is already 8-bit ASCII. So we do not have to add 0 here. So you see here 1, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. So 8, 1, 1, 2, 3, 4, 5, 6, 7, 8. So in this way you can convert any of the number. For example, if you take 999, and please remember that you can sorry, you can increase this particular scale infinitely. And suppose I have taken as 2 to the power 9, so maximum number what it can represent up to 1024. So 512 into 2. If I need that, okay, I need more than 1024. So what I'll do, I'll simply add or increase this particular scale. So another column uh, you know insert another column to the left. So I can write here that 2 to the power 10 is equal to 10224. So I can now represent 2 to the power 10, 1024. So I can now represent 1024 into 2 as a maximum value. So 999 is, well, we can represent within the 2 to the power 9. So here 512 is present, 256 is present, 256 is present, 128 is present, 64 is present, 32 is present. Now let us take add up this particular value to know what is happening. So we have added 512 plus, okay, 512, okay, this happened. 512 plus 256. So it is basically 8, 6, and 7, 768, plus we have also added 128. Now it becomes 4, sorry, 6, then 9, and 8. Now we have added 64 with it. So it now become 0, 6, 9, 960. Then we have 32 we have added. So 32 is equal to 992. So almost 992 we have covered. Another 7 remains. So 16 will not be there. Absence. 8 will not be there. But 4 can be there, 2 can be there, and 1 can be there. So altogether you see, now if I add with it 4 plus 2 plus 1, so it becomes 999. So 999 decimal will become 1151 actually, double zero triple one. So this is the binary representation of decibel 999. So in this way, any number you can represent with its binary equivalent. Any binary equivalent can be converted to into their decimal equivalent by using the same scale. So suppose what is the decimal value of binary, say 111. So you just represent, or say 11011. So last bit 1011. So you can easily understand that what is the decimal equivalent of this binary number 11011. So what we need to do, we need to take 1 into 2 to the power 0. So that is 1 into 1 plus 1 into 2 to the power 1, 1 into 2 plus, you can see here this 2 to the power 2 square, anything to the power 0, anything into 0 is also a 0. So 0 into 4 plus 1 into 8 plus 1 into 60. So altogether you can see the binary equivalent is 1 plus 2 plus 0 plus 8 plus 16 is equal to 24, 26, 27. So binary equivalent of 11011 is 27. And from the, by utilizing the same scale, in this way we can generate that particular number. Okay. So now we are coming to the main part, the ASCII part. So what is ASCII? ASCII is basically a standard code which represents every character available in your computer keyboard. Normally there are 104 number of keys in general, or 101 to 104 number of keys. So all keys available in your computer keyboard are basically mapped with a ASCII value. So for example, for this A is a character, this is called ASCII character, and the ASCII value of A is 65. Similarly, there is a character B, capital B, which is having ASCII value 66. There is a small character, say lowercase a, which has ASCII value 97. So in this way, similarly small b has 98 and so on. So every character in your computer keyboard, including your enter, your control, space bar, right control, left control, shift, star, parenthesis, everything is attached with a corresponding ASCII value. And when you are writing A, what is happening actually inside your computer? When you are writing A inside your computer, this particular thing is happening. So 65 is immediately converted into its binary equivalent, and then this particular binary equivalent is getting stored inside your you know inside your system as this particular symbol. So one particular this figure is missing. Let me add one. Insert, save this one. So I'm adding another thing for 0, this last 0. So now you can see, you can easily understand. So the moment your ASCII character is converted by taking the value of ASCII value of the ASCII scheme available in your laptop or desktop, it is converted into its binary equivalent, and then binary equivalent is getting stored inside your hard disk, something like that, something a combination of a symbol. So when next day you retrieve that particular file which is having only A, the signal is converted to binary equivalent converted to the ASCII value, and the corresponding ASCII character is represented here. So this is the process what we normally use. But what is the problem with that this particular ASCII key? Why we cannot utilize it for our Indian regional languages? The problem is that it's an American code for information interchange, and it's either a 7-bit ASCII code which can represent maximum 128 number of unique character, or it can be a 8-bit ASCII code which can represent 256 number of unique character. So this particular thing is based on a mathematics. So the formula is 2 to the power n, where n represent number of bit. So here you see, when bit is 7, it is 2 to the power 7 is equal to 128. When bit is 8, it is 2 to the power 8, 256 is the value, and 256 number of unique character can be represented. And this particular ASCII standard is heavily biased towards Roman script. So it is biased towards Roman script, particularly Latin character set, and 256 number of unique character cannot accommodate all the scripts of the world. So in India, Department of Electronics in mid 80s developed a standard called ISCI, and ISCI is nothing but an extended ASCII, and it's of course 8-bit. Okay, so what it does, it very cleverly it converted the extended ASCII, which is a 8-bit code, 256 number of characters are there. So 128 character for Roman script, and 100 character for any one Indian language. So it can be Bengali, it can be Hindi, and so on. Latter part of the presentation, I will show you how it is possible. So 128 number of characters they reserved for the ASCII, where all the ASCII character 0 to 127, which are normally associated like A, B, C, D, common characters, are same. Then remaining 128 characters they have utilized for any one Indian language for multilingual computing. So ISCI, you can say it's a bilingual. Maximum it can represent bilingual text encoding system. So one English, another is any one Indian language like Hindi, Gujarati, Punjabi, Bengali, Tamil, Assamia, and so on. Now, this is not quite sufficient. So, in the decade of 90s, most of the software giants like Microsoft, Oracle, Sybase, Google all came together and developed a Unicode character encoding system. Because ASCII and ISCII, it's a 1 byte code. You see, 8-bit means 1 byte. So what Unicode proposed, that in place of 1 byte, it will be a 2 byte code. 2 byte means it can represent 2 to the power 16 number of character. So it can now represent 2 to the power 16 number of character. And what is 2 to the power 16? Actually, it's basically 65,536. So now it is possible, as we have increased the base from 1 byte to 2 byte. Now in place of 256 number of character, we can accommodate 65,536 number of unique characters. And it has been calculated that for the entire world, 50,000 unique representation is just sufficient, including some of the obsolete script like Brahmi, Kharosthi, and so on. So all the present language, all the past languages, the script, if the script is available, can be represented through this Unicode. So from mid, beginning of the first decade of 21st century, that is the 2000 and 2001 onward, most of the software database management system, hardware capabilities are tuned towards Unicode, and now Unicode is the global de facto text encoding scheme in place of ASCII because we can represent any number of languages. So, with this brief introduction, let us now move to the presentation part. So, how multi-script computing through open source software can be done, particularly for the purpose of library retrieval. Amazingly, you know that less than 5% of people in India can read, write, and speak in English. So 95% people are basically, sufferer of digital divide if we are not able to, provide multilingual computing. So multilingual computing is very essential for a country like India, where if you go through the plane, in every 400 kilometer, our language changes. I am in Bengal. Another 400 kilometer I pass through, that is Bihar and UP. The language is Hindi. If I again cross Delhi, the language is something different. And if you go to the northeastern part of India, particularly hilly area, their language changes in every 4 kilometer. So that is the diverse number of languages we are having. More than 411 number of languages we are having, including if you consider dialect, that goes around 13,000. So that is the situation of our country. It's a big multilingual country, so we need multilingual computing. By 2025, Hindi and Bengali will be in the top 5 mostly spoken languages of the world. And why Bengali came here? Because you see, Bengali is not only the language of a province of India in West Bengal. It is also the national language of a sovereign country like Bangladesh. So altogether, by the number of speakers, Hindi and Bengali will be coming in the top 5 by 2025. It has been calculated or measured by a very respectable research organization in language that is called Ethnologue. And they have a very good website also, Ethnologue. You can search it. So resources in Indian languages are increasing. If you go through different language version of Wikipedia like Hindi Wikipedia, Bengali Wikipedia, Gujarati Wikipedia, you can observe this particular trend. Library systems in India need multi-script information retrieval system so that people can search in their own native language. They can have their virtual keyboard attached with the system, and they can search, and your library system must respond against the regional language searching, which therefore your system must be Unicode compliant. And Unicode compliance is not the only thing. You need many other adjustment. Many other adjustment will be going through the next tutorial, that how your default Zebra search engine of Poha can be tuned towards Indian languages. So many adjustment we need actually, but before that we need to have an idea what is multilingual compatibility. Now, such need of such system is surprisingly higher in case of college, school, and public libraries. So most of the cases, college, school, and public libraries in our country are poorly funded, whereas university, IITs, IIMs, CSR labs, they are heavily funded. But they do not have any kind of requirement for multilingual document. A scientist never ask a article in Hindi or in Bengali. There, the lingua franca is English. The science is basically dominated by English language. So, in the higher education domain, possibly you do not need this technology. But these technologies are much more required for the lower strata of the libraries like public library, school library, college library, and they are not, funded enough to adapt multilingual computing system inside the library management process. So, open source, open standards can be a rescue option in this particular direction. So we need to know that how we can apply different kind of standards apart from Unicode in achieving multilingual computing. So as I already discussed in the first part of the demonstration, that ASCII remained de facto text encoding standard for a long time, right from the decade of 60s. And in the 90s only, we realized that ASCII is not quite sufficient for multilingual computing. It's a one byte code. It can represent maximum 256 number of characters, heavily biased towards the Western world, mainly cover different kind of Romance language or Roman script or Latin set of characters, and do not take care of different kind of scripting technology in Indian subcontinent. So we need a different text encoding system, and Unicode is the result. But before that, let's have a look at the history. You know, in India, we call it an Indian subcontinent. If you take into account all the part of the country like Bangladesh, Pakistan, India, Sri Lanka, all together we form a subcontinent. And in this subcontinent, every language, including Urdu, in Pakistan or Singholi in Sri Lanka are all originated from one particular script which is called Brahmi script. So in the 3rd century BC, it originated as a script in this Indian subcontinent, and again it took a sharp turn in the 1st century CE after Christ, that is the northern script and southern script. Northern script is actually this is the modern script, Gurumukhi, Devanagari, Gujarati, Bengali, Oriya. These are all originated from Brahmi but passed through a revision here in the northern script. Similarly, if you go to through this Dravidian language group, southern script, Telugu, Tamil, Kannada, Malayalam, all scripts actually originated from Brahmi, including Urdu and Singhal in this entire Indian subcontinent. So, origin is Brahmi script. We have two major groups of languages in India, northern script and southern script. We have 407 number of living languages. Remember, we have 407 number of living languages, only 22 are constitutionally recognized. So do not think that only constitutionally recognized languages are only available in India. And we have already 11 languages already extinct. So presently we have 22 constitutionally recognized languages, and these 22 languages can be represented through 10 different scripts. So in multilingual computing, language does not hold the key. Script hold the key. So normally in Bengali we call it lipi. In Hindi maybe it is called a lipi or Varnamala, alphabets. So script holds the key. In multilingual computing, you never take care of the language. You always take care of the script. I'm just giving one particular example. Say, Devanagari is the most popular script in India, and on the top of this particular script, there are many different languages available. For example, Hindi, the most visible one. Then comes Konkani, Nepali, Marathi, Maithili, Bhojpuri. All are based on Devanagari script. So one script can represent multiple languages. And again, if you take the example of Bengali script, so script is the Bengali, and the language it can represent Bengali as a language, Assamia a little with little bit of modification, but presently Unicode represented that particular script as Assamia Bengali script. So with little bit of modification, the same script can be utilized for Assamia language. And then there is a language in Arunachal Pradesh called Moiti. Then there is a language in Manipur called Vishnupriya Manipuri. There is a language in adjacent area in northeast that is called Sileti. All are based on Bengali script. So one particular script that is one of the unity in diversity in India. One script can represent many languages, and that is a beneficial in point of view of the multilingual computing. So as I said that ASCII was limited, it can represent only 8 number of bits and maximum 256 number of character, heavily biased towards the Western world. So we came up with our own standard in 1983 by the initiative taken by through Department of Electronics, the then Department of Electronics. Now it is called Ministry of Information Technology. So they developed ISCI, Indian Standard Code for Information Interchange. It's nothing but extended ASCII. But that extended ASCII of 88 actually becoming a Indian national standard in 1991, that is called BIS, Bureau of Indian Standard, adopted SK88 as our national standard for text encoding scheme in 1991. CDAC came up with a solution that is called gist card bed solution, through which we can enter English language and any one Indian language at any given point of time. Different kind of sister project came, ISFOC, iTrains, and so on. But all of these projects superseded with the entry of Unicode. Unicode is now the global de facto standard for every language. In place of ISCSI and ASCII, which were 1 byte code, now it is a 2 byte code. 2 to the power 16 number of characters can be represented. It is universal, efficient, and convertible. It is based on the Indian code space. Code space for Indian languages are based on ISCSI 88, which is a BIS standard. And present version is not 5.0. I have wrongly written it. Present version of Unicode is possibly 9.0, and it can be represented into three different formats: UTF-8, UTF-16, and UTF-32. Presently in the web, or the software we are using, which are web based on web architecture, we take UTF-8 as our default character set for Unicode. UTF-8, what is the specialty, why people are adapting UTF-8 as a UCS or Unicode character system? Because UTF-8 will be reducing the network overhead. Suppose I have a document which is written both in English and Hindi. So it will convert the English part in 8-bit and the Hindi part as 16-bit, because originally Unicode is a 16-bit code. So all non-English languages or script will be represented through 16-bit, and English character, Arabic, Indo-Arabic numerals, all will be represented through 8-bit. So that is actually you know taking less network coverage and bandwidth, because the size of the file will be reduced. Because you see, if we take 1 byte, one character takes 1 byte principle. So if your file includes 10 character, that means it is a 10 bytes file size. So the in 8-bit ASCII, if you convert that in 16-bit ASCII, or 16-bit Unicode, then immediately the file size will be double. Now 10 characters takes 2 bytes each, so 20 bytes. So if you use UTF-8, your English character will be in 8-bit and non-English characters will be in 16-bit, so file size will be reduced in this way. That's why UTF-8 we are using in case of different kind of web enabled library management system like Koha or DSpace, Greenstone, and so on. And this is the code space for index scripts in Unicode. Here it starts with Arabic, then comes Devanagari, Bengali, Gurumukhi, Gujarati, Odia, and so on. And here one particular characteristic feature I would like to draw your attention on it. Say this particular 2304 is basically, suppose, Hindi O. Now you add 128 with it, you will be getting Bengali O. You add another 128 with it, you will be getting Gurumukhi O. So in this way, auto transliteration is also possible in case of Unicode code space. So every block has given 128 number of characters. If you add 2304 plus 127, the end number is 2431. Then 2432 plus 127, 2559, and so on. So every language, Indian language, has given 128 number of characters, and that's why they have a unique capability of transliterating, auto transliteration from one character to another corresponding character in another Indian language. So this is basically, if we represent this one, this is basically the Bengali language, Bengali script in Unicode, how it is represented Unicode in Unicode, and why I am saying so, because here you see the scope of transliteration. If we place here side by side Devanagari, Hindi, Devanagari, Bengali, and Tamil, three scripts. Here you see they are basically placed in such a clever way. So these vowels o represent Bengali o and then Tamil o. So side by side, you can compare different kind of representation through script, in different Indian language script. So an auto transliteration is possible, but there is a difference between transliteration and translation. I hope you can remember the difference. What is the difference between translation and transliteration? Transliteration is mechanical, automatic conversion of one character of one language in through the another character of another language. So that auto transliteration is possible because of this kind of clever placement of Indian language code space in Unicode. Next important thing you need to understand is what is rendering, because uh, in Indian languages, as I already mentioned, that there is a unity in diversity. And what are those unities? Let me tell you some of the unities in Indian script, because they have all originated from the same Brahmi script. The number of vowels are same. The vowels basically in Bengali language we say o, a, hasoi, dirghoi, hasu, dirgho. So these vowels are common in every Indian languages. That is the first unity. Second unity is that number of alphabets, what we call in Hindi, aksar, are quite common, and in and around 50. So in Bengali, we have 54 number of characters. Similarly, in Tamil, we have 51 number of characters, and so on. And that is the second unity. Third is that every Indian language adapt a unique capability of creating mm, different kind of alphabets through combination, what we call zuktakkar. So one character, consonant consonant, consonant vowel can be integrated with each other through different permutation combination and can create different glyph. So uh, 54 number of character alphabets in Bengali can be combined to create 2.5 thousand different glyphs, and this is one example of such glyph. Say for example, I have given here purti. So normally it appears there are only two characters, but actually in reality it is a combination of six different characters. So these six different characters, they are combined with each other, and these glyphs they can generate. So this is a consonant vowel integration. This is a consonant vowel complex integration. So one, two, three, four, five, six, how they are combined and giving this particular glyph. Now Unicode is a standard for the font, for the character, not for the font, not for the glyph. So Unicode is a character standard. So every character is represented by Unicode, value. So how this glyph can be generated for Indian language? There we need another text rendering process engine. So every Indian language requires not only Unicode, but to represent this Zuktakkar properly, we need a text rendering engine for representing different kind of glyphs. Glyphs are basically complex character by combining consonant with vowel or consonant with consonant. So that is one of the important issue in Indian languages, rendering of the character, that is the glyph sourcing. And here I am giving some example for my own language Bengali, but you can easily understand in different other languages. So this is ko, how it is combining with vowel. So this particular vowel is hossoi, which is the, and this is the gizmo of hossoi, the shorthand side of hossoi. So this particular consonant is integrating this vowel and creating this glyph. So it can be different vowel, hossoi, o, and so on. And it can be consonant consonant combination also. For example, this third, here it is represent class. So it is represent integrating ko with law. So we are getting a clip like ko, koi, loy, we call it, and hopefully you can understand or you can contextualize it in your own language. So different kind of such example I have given, where consonant vowel, consonant consonant combinations are juktakkar, and how these are represented through gizmos or through shorthand side. and these are called basically clips. So as far as our requirements are concerned, in particularly library information system management in the context of multilingual computing, we need Unicode as is a must as a text encoding system. But apart from Unicode, we need to ensure our entire operating system is Unicode compatible. All Linux distributions, Ubuntu, Debian, Fedora, CentOS, and you name it, we have it. All are Unicode compliant. All the latest Windows operating system, right from Windows XP, are Unicode compliant. Your text editor must be Unicode compliant because in most of the cases you are writing your programming and your different kind of messages in text, as a text file. So your text editor must be Unicode compliant to represent your multilingual character. Your programming environment, what you are using, PHP, Perl, Visual Basic, C, C++, Java, JSP, ASP, any programming environment you are using, or Ruby on Rails must be Unicode compliant. And most of this open source programming environment like PHP, Perl, Ruby on Rails, the entire LAMP architecture, all are Unicode compliant. And the most important factor is the database management system. The backend database management system like MariaDB, MySQL, PostgreSQL must support Unicode 8, and most importantly UTF-8. Sorry, not Unicode 8. Unicode as a text encoding system, and UTF-8 as a character encoding system within the Unicode must be supported by that backend database management system. Otherwise, your data, multilingual data, will not be stored properly, cannot be retrieved properly. So that is the overall system level part. You can see that requirements I have divided into two groups. One is the system part common to each language, each Indian languages. Then comes the language specific part. For example, we need a virtual keyboard if we want to enter data in Hindi or Bengali. So one virtual keyboard can represent only one language, like Obfro, it's very common in Bengali, or in Hindi, in Devrati script is Bolnagri, very common to many of these, uh, Hindi language worker. So these are exclusive virtual keyboard, Unicode compliant virtual keyboard for a given language. But the current trend is that multiple languages can be supported through a single virtual keyboard. Many such virtual keyboards are available with your browser, as most of our library management softwares are web architecture based. Browser is the client part. So those can be tried, and it will be easier for your users also. So that is the virtual keyboard, Unicode compliant virtual keyboard. Then language, as I said that in every Indian language we need rendering engine specific to that particular language, because dips are not same. And fortunately we do not have to use different rendering engine for different Indian languages. If you are using Linux operating system, there is called Pango rendering engine, which can handle all 22 constitutionally recognized languages. Rendering process can be tackled by it. If you are using Windows, there is USP10.dll, which is again a common rendering engine which can handle all Indian scripts. And the third requirement is font related to that particular language. And most of the cases we are using open type fonts or OTF. Previously we were using true type fonts, TTF. Now we are using OTF, open type fonts. For every language, you can you can be having lot many open type fonts. And one of the great things, initiative has taken by TDIL, Technology Development for Indian Languages. If you search TDIL, Technology Development for Indian Languages in your any search engine, you will go to the home page and you can see for all constitutionally recognized languages, they have developed beautiful open type fonts that you can download and you can install inside your computer, both in Linux and Windows. And another one, what I normally prefer, that is a font family generated or developed by Google, that is called Google Noto. The Noto family includes many of the languages of the world, including Indian languages. So if you install Google Noto font family as OTF, then any Indian language, any languages of the world can be represented or can be handled by your computer. So that is the requirement level, system level, and language level. So most of the cases in operating system, as I said, many of the Linux variant. I have given example of Fedora, but it includes definitely Ubuntu, Debian, and so on. And Windows XP onward, like Windows 10, 11. Text editor like Notepad, Unipad, Gedit, Nano, all are Unicode compliant. Flash-based tool programming environment, PHP, Perl, JSP, automated library system like Koha, Greenstone, DSpace, all can be Unicode multilingual compatible. In the next tutorial, we will be learning how Koha text retrieval engine can be tuned to handle multilingual character. Then virtual keyboard, for example, in case of Bengali language, you can use Opro. In case of Hindi, Bolnagri is there, or you can use, as I said, a different kind of browser compatible virtual keyboard for your user for easy typing. Rendering engine for Windows operating system USB 10.dll, for Linux it is Mango, and different open type fonts are available. For example, in Bengali we are using Likhon or FBFP. FBFP is a project of Bangladesh. They call it Ekuse Bangla. So Ekuse Bangla, Ekuse February, you know that 21st February is the World Mother Language Day in the memory of matriarch in Bangladesh for struggling to include Bengali as their mother tongue in place of Urdu. So they have developed in the memory of 21st February or 21st February, more importantly remembered as, and they dedicated that particular project to develop different kind of open type fonts in Bengali, and that can also be utilized. So we right from the mid 20 middle of the first decade of 21st century, we tried this technology with many of the system. We checked whether Google is compatible or not. Google now it's a completely Unicode compatible. Your Wikidata, Wikipedia, all are Unicode compliant now. Many search engines are compliant. We developed way back in 2000, 4 5, the complete Bengali language interface of DSpace for our one of our university. Then it can retrieve, it can browse, you can search, interface, everything you can do. So another interface of DSpace, the mannequin that we have converted into Bengali, and many of you may not be remembering, but this is the one of the search interface or opaque interface of Koha in version 2.x. So right from the version 2.x we can convert Koha into Bengali language. And that was the historical opaque we have designed. We designed actually long back in 2007 as part of one of the PhD project, and that can retrieve. So this is the librarian interface. So what I'm trying to show you this old screen snapshots of different Bengali language snapshot to just make it sure that you don't think that this is the very recent phenomenon. People are trying this to achieve multilingual computing in Poha, DSpace, Brainstorm, in the right from 2000 when Unicode came into picture, and that was very successful actually. So in case of similarly like Koha, we have also converted this greenstone in different kind of retrieval. You can even go for TF-ITF model of retrieval where you can give different kind of weightage for different kind of search terms, and everything you can represent in Indian language. As an example, I have given Bengali language here. I can enter data in Bengali, and that's all for the representation. I do hope that You now understand what is Unicode, what are the requirements of multilingual computing in India, and how it is possible to convert or to fine tune our different library management software as Unicode compliant multilingual information retrieval system. So that's all for this tutorial. Let's uh, mm, let's stop it here.